Good morning, sirs and madam. I wish you are all well and always in a good health. Today, I'm so glad to be able to do a solution sharing with you all about Epicor IPNO. IPNO is inventory planning and optimization. This is one of Epicor product portfolio that brings an AI power inside this solution. Today, we'll talk about how organizations can maximize profitability using AI driven inventory planning and optimization, or IPNO. My name is Joe Marcelo as a solution engineer for Southeast Asia. Before we start, it is a corporate requirement to bring this safe harbor statement. Okay, next. So, just fundamentally, what is IPNO? It is a SaaS product for demand forecasting and stocking policy optimizations. It fundamentally does two things. One, it generates statistical forecast of demand, manage those forecasts, and track accuracy. Two, it optimizes stocking policies with respect to desired service level and cost. Epicor IPNO is a solution to optimize demand and inventory. It is a state-of-the-art technology. It enables organizations to operate high-level standard of supply chain practices. The results are reduced stock out and increased revenue, reduce inventory and cost, improve forecast accuracy, predict the final impact of alternative planning policies, track history and operational performance, promote organization consensus. Now, why we need another solution for inventory planning and optimization? Inventory is often the largest working capital investment. Yet, many companies still manage it with outdated assumptions and static rules. I'll share why traditional ERP based planning struggles, and we will look into some common problems and challenges that we all see in real life situations. I have compiled some, and in next 5 slides we will look into it quickly. Start with our standard ERP. ERP planning parameters like safety stock, min and max, and reorder point are numbers that we decide to put into the parameters. It is called deterministic. We often assume demand is stable, which is rarely true. This leads to habit of like safety stock on top of another safety stock. For example, a sales increased the forecast with buffer and then planner put another buffer, and then the result we are overburdened with raw material and causing us issues. The core issue is that deterministic model can't represent uncertainty. Human judgment fills the gap, then often doubling the protection unnecessarily. ERP typically generates single number forecast, like we will sell 10 units, but demand doesn't behave that way. It is a range of possibilities. Without what if analysis, planners can't see how parameters change affect stock out risk. For example, a buyer orders 6 months of supply just to get a shipping discount. The order quantity is optimized for logistic cost, not demand reality. When demand shifts, the warehouse fills up with the wrong inventory. This is a typical problem with rules of thumb. Like, we need to carry 2 months of supply. Okay, sounds reasonable, but they will break down fast. One item might have a stable demand, while another is highly volatile. Applying the same rule leads to overstock on one item and shortage to another. This slide shows how average-based thinking hides variability. IPNO shift the mindset from average to probability, ensuring each item gets the right policy based on its actual behavior. Another issue is set and forget inventory parameters. Many inventory parameters are set during ERP go live and never revisited, but market change and move constantly. A good example is product lifecycle changes. Like a hot new product gets high safety stock, but then 2 years later, it is in decline and the parameter stays the same. ERPs don't automatically recalibrate settings as demand or lead time change, leading to excess and obsolete inventory. When planners don't trust ERP outputs, they export data to Excel. This creates silos, version control issues, and manual errors. Another common problem is one size fits all service level. Like we are applying a 96% target to all SKUs. That overinvests in slow moving, low margin items while potentially underserving a critical A item. Without visibility and automation, manual overrides quickly push parameters further away from reality. A real world complexity ERP can't handle. Like inventory planning doesn't happen in a clean system. Lead times vary, master data is often wrong, and systems like POS, WMS, and marketplace aren't fully integrated. A great example is lead time variability. An ERP assumes 30 days, but reality range from 35 to 50, for example. Planning based on a fixed number creates frequent stockouts. Traditional ERP logic assumes consistently, while the real world is messy and uncertain. Those are more or less the problem in real life about inventory management. This slide summarizes how many organizations operate today reactively. Inventory policies are only adjusted after stock out or problem occurs. The cycle becomes guess, increase inventory, wait, and guess again. This reactive loop increase cost and volatility. The key message here is that reacting to bad outcomes is far more expensive than proactively managing risk using probability based planning. Epicor inventory planning and optimization. What makes it different? First, Epicor IPNO use field proven probabilistic forecast modeling. This is not your traditional forecast. Leveraging inventory transaction stored in your ERP system, it generates thousands of demand and lead time simulations using real ERP transaction data. Instead of single forecast, IPNO technology generate thousands of realistic demand and lead time simulations for every one of your items. IPNO tests different stocking policies against these scenarios to see which policy perform best. Optimized parameters are continuously updated back into Epicor ERP, such as safety stock, reorder points, and order quantities. This ensures planning stays aligned with daily changes in demand, cost, and business priorities. IPNO Solutions enables your organization to focus on the transition from reactive to prescriptive, from fixing shortage after they happen to using probabilistic modeling to predict and prevent them. The strength lies in its ability to integrate with Epicor ERP to push optimized parameter back into the system of record automatically. IPNO is a cloud-based platform with bidirectional ERP integration. It supports what-if analysis, lead time analysis, and policy optimization using advanced statistical models. This includes exponential smoothing, seasonal models, and bootstrapping for intermittent demand, and so on. The key point here is in memorizing models. It is knowing the system automatically select the right technique for each demand pattern. Now that we have discussed the challenge and the conceptual solution, let's look at IPNO in action. We will start with demand planning first before looking into inventory performance. This is Epicor IPNO demand planning solution. A powerful tool for managing forecast, generating forecast, tracking accuracy on that forecast, and then sign off those forecasts before it updates forecast entry in Epicor ERP. Demand planning is organized by project. It is because normally we are not working on all product at once. We normally have a categorization or grouping of our products. In this example, we have 5 product groups, and at any time, planner is going to see this in the first screen. We have had historical data coming from Epicor ERP from 2022 until 2025. Based on this history, demand planning has generated the 12 months forecast for 2026. As you can see here, this is the number, but we do not stop with getting this number into our forecast entry in our Epicor system. We need to analyze further by finding the odds. Odds mean probabilities, likelihood, or chances. We can see more stories if we see the graphical view of our demand history and forecast of 2026. Let's look at the product group FABP, for example. This red lines is the demand history per month based on our Epicor ERP data. We have had a few years back of data. This green line is rolling forecast going for 12 months. Like I explained in the presentation, Epicor IPNO is multi-probabilistic forecast modeling, and it runs statistical modeling and simulations. Then test different models against this scenario to see which model perform best. The system implement various different statistical approach that well suit to the different kind of data. Some data is going to be seasonal, some data is going to be a trend, some data might be very spiky and intermittent or can be flat. Epicor Demand Planner does all the work for us as far as deciding which one to use and where. Like in this FABP product group, we can notice that actually our demand history was shaping a pattern. Then IPNO recognized that pattern, then forecast accordingly. We are now working in a group level. We can see that lower level by expanding this data. Let's see in individual part. For example, this 0201223. It is showing a slightly different graphical view compared to group FABP. Okay, we can work down to part and location level. Where we can see a very specific demand history of part 0201223 in location Chicago. We can notice that the visualization of demand history and forecast is also slightly different from FABP product group and from part level. I'm showing you another example to contrast the forecasting as a result from different pattern of historical data. We are looking at part DSS 800 in this example. Even though we are seeing a spike at October, November, and December, however, system doesn't consider a need to respond that and give us a flat forecast. The functionality doesn't just stop here. We have capability to adjust the forecast. Let's take example. Our sales, for example, just secure a contract on this product. So we are sure that we are selling this product and plan to receive a gradually higher demand. So we can work like this, moving up this demand to anticipate the demand that coming to our business. Then we can put notes here. Let's say new contract is coming. That's how the way we operate in part and location level. But in reality, normally we are not working in part level. Imagine how many parts we will have to check, review, and adjust if necessary. We are talking about hundreds or thousands of products. The insight that we have on forecast might not be at the part or location level. That's why we have this hierarchy set up. At minimum, we will have to work at product group level. Let's say in the room with executive directors or managers, what they are talking about is, for example, audio product line, beverage product line, or diecast casing product line, and so on. They are talking as a whole, as a group. We can take care of that very easily by going to the forecast tab and click the numbers on relevant month, then change it anyway. For example, click here, change this, double click, and put it 160. Rather than having to go part by part and by location, we can make the change up here and let Epicor reconcile and blow that demand out through the part mix within the group. Why does this matter? By having this different level of aggregation and different level of detail, we can make sure that different stakeholders in the business can bring their insight into the plan. Each person may think about demand and forecast in very different ways. And we don't have to worry about all the exhausting details of reconciliation or how this adjustment roll up, roll down. You can see the tooltip here. Original is 70, so the system keeps the original value. So we are aware from what number and change or updated to what numbers. So with this, we can focus on the process of forecasting. Once we satisfy with this, once we have established the plan and we have a forecast that we like, we sign off and send it off into forecast entry. All the work that we have just done are all saved and synchronized to Epicor ERP forecast entry. So far, so good. This system is a powerful extension of forecast entry. Here, we can run scenarios around planning, consider multiple forecasts, and adjust those forecasts accordingly. We review them, then push to ERP and start running MRP against them. Over the time, we are naturally want to compare how is our forecasting to actual. Here we have a tab forecast versus actual. Let's say we look back over a 3 months period. Just simply type 3 here, means 3 months. Then we calculate what Epicor Demand Planner doing is storing and remembering the forecast that we have generated, because we want to go back and ask what did we forecast 3 months ago versus what actually happened. Where are we missing? How far is it different? Do we see exceptions? Here you can see what we forecasted over the last 3 months and compare to the actual. Now we see the summary. We can see that on average, we are over forecast on 63%. We are under forecast on 36%. And we forecast accurately on 1%. So in total, we are 20% off from actual. So this is the metric around bias. This shows us how many we are over forecast, how many under forecast, and this is the comparison of the 3 months forecast compared to actual. Again, for example, we are forecasting all these 5 product groups, and we can check here, seeing our error percent. It looks like our apparel still okay, hardware still okay, around 20% error, but it is not going very good with MBLD groups and FABP groups, where it is off by 100 more percent and 400%. We can go back to the graph and see what happened during the month, for example, and we can notice there are significant drops in this month, like October, November, and December. Is that expected? What happened during those months? Or maybe the historical data is incorrect? If this is the case of our company, the answer will be different from one another. The key is that we are using metrics automatically generated by the platform to direct our attention to where we should be spending our time. So, this is the forecast piece. This is one part of IPNO. Again, forecast is always uncertain, especially for businesses with products where the demand is intermittent, spiky, or unexpected. That's where it becomes critical to pay equal or greater attention to the buffers around the forecast. Those buffers come into the form of min, max, and safety stock, which are ultimately what catch us when we miss the forecast. What Epicor IPNO is doing here is predicting the odds. Okay, IPNO has all the data required, historical demand, and the forecast from the ERP system. It has all lead times, and IPNO also has a carbon copy of the min and maxes as they are currently exist in part maintenance from our Epicor ERP. Those are referred to live scenario. So these data are coming from live system. The system runs simulation and stress test against those policies and predicts the odds of stocking out. That is expressed as a predicted service level. Average SL here means average service level percentage. This tells us that in our current life system, we should expect to fill the demand on time and in full about 80.94% of the time. Let's say 81%. In the other words, we are talking about 19% stock out risk. This also tells us in our current life system carries about 7.6 something million inventory in the book. We have more parameters to work on. Let's see drivers here. If we look at the distribution, we can see that the spread of predicted service level is at the item level. This tells us that every part and location is getting its own stress test and prediction. This is an average of 76.9, okay, 77%. Seems okay. But with floor reordering cycle, 0% is so worrying. It means that there are products that for sure not available when needed and need replenishment. And the ceiling here is 100% is also worrying. It means there are products that are always available when needed. This is an indication of overstock or slow moving or dead stock. This indicates opportunities to pull inventory down before excess builds. This is where the AI uncovers all facts and present it to us. How we optimize this? Simply by setting the floor here, let's put 85%. Of course, 85% surface level at minimum is way much better than 0%. Correct? And the ceiling, let's put here 99. Again, from 100 to 99 surface level is still at excellent level. Even 95 or 90. When finished, click apply to all. Then the system updates all the products and policy instantly. Before looking at the detail here, let's look the result in summary metrics. We see the net impact of the what ifs. So this is previously our current life system calculation, and this is what if after we input the parameters to the drivers. In this case, the average surface level can achieve about 93.59. Of course, this is much better than 81 previously. And the consequences, we will carry like 7.8 million average inventory value because we are increasing the 0 to 85. And we carry total annual operating cost goes down from 2.6 million to 2.1 million. There are about 500,000 reduction on this one. Perhaps we are not satisfied with the what if result in the inventory average value. We can go back to the drivers and change something. Let's say put this 95 and reduce this to 80. Apply again. Then we go back to see the result in summary metrics. So again, from the what if scenario, after the system recalibrate all the parameters, they calculates our average surface level still good at 93%, and the total inventory value goes down from 7.6 million to 6.8 million. That is like 800,000 reduction, and of course this bring us a good news on the result. Most importantly, we can allocate inventory spending from the wrong place to the right place. In practice, not all parts are created equal. Some items are more critical, used in many products, and worth extra investment. Other may have short lead times or reliable suppliers, allowing more risk. We can shape policies by attribute or groups. For example, IPNO automatically classifies item by volume and frequency similar to ABC classification. We can isolate fast-moving products. Now, The summary reflects only those items. We are working now in only high volume, high frequency groups. If sales says we can never run out of fast movers, we can model what that means. We can set the floor to 99 and ceiling also 99. Then apply, and we go back and check. This will give us 99.5 surface level, but the consequences, we will carry a higher inventory value like 900,000 something, and the annual operating cost is about similar. So then we can ask, what about like 98% or 95%? Each time we do it, we can have an instant feedback. Let's do the same simulation as before and go back to check. Okay, we can still achieve 99%. Inventory value still above the current live system, but annual operating costs we can save like reduced 100,000. Again, try 95 and let's see the result. Go back here. We still able to maintain 97%. Of course, this is a good numbers as a surface level, but you will see the inventory value reduced from 5.2 to 5.1. Okay, with this what if scenario, we could jump back to the driver and make changes, then jump again to summary metric to find out exactly what that scenario might look like. So we don't guess at min, max, and weeks of supply. We specify the risk tolerance and we let the system compute the policies. We can still dig into individual item to see that it is updated. We can see here the lead times. Let us select one item. So we here click the little plus sign. We can see the individual what if for any item. So for this product in live scenario, based on current policy, our predicted service level is 99 and we bring down to 95. So the reorder point value from 2.5 million, we bring down to 2.2. Order per year still the same, and average inventory value we bring down from 1.7 to 1.4. Also the operating cost and safety stock value, we have done a good reduction on what's important in our inventory. Let's pick another one. We select lines that has good numbers. For example, this one, current life system surface level is 97. Then we bring down to 95 with the consequences. Reorder point value we reduce like 330 something thousand. Average inventory value we reduced 30,000 something. And of course also the operating cost and stock value showing a good reduction. All right. So once again, we are deploying a surface level targets. This is all the AI is using analysis to compute what policies is required to meet those objectives. When we establish the policies, we click save, then synchronize them off into part maintenance in our Epicor ERP. Similar thinking here, the inventory optimization workbench is extension of the execution level in core ERP. We can run what if scenarios to our hard content, predict and understand the impact ahead of time. And when we are ready to make the change and recalibrate them, we simply update those fields over into part maintenance. All right, I think I have concluded the two parts of the IPNO, demand planner and inventory optimization. Let's go back the slide. To wrap up, inventory optimization is no longer about static rules, average, or gut feel. It is about managing uncertainty with probability and automation. Epicor IPNO enables organization to improve service, reduce working capital, and align teams around data-driven decision. Thank you for your time, and I look forward to your questions or discussion on how this can apply to your organization.